Hello everyone, welcome to the channel. In today's video, we are going to be discussing IGCSE Mathematics. This is 0580 paper 2-1 from the May June 2024 series. Here we go. Question 1. The diagram shows two sides of a parallelogram ABCD. Find the coordinates of point D. Now we know in a parallelogram, we would have two pairs of parallel sides. For example, this would be parallel and this would be parallel, right? Okay, so now to find our coordinates of point D, we can trace the line from B to C. So from B to C, we are effectively moving 1, 2, 3, 4 units to the right and 1, 2 units up. So moving 4 units to the right and 2 units up. So we can trace the same path from A to our eventual coordinate D. So moving 4 units to the right, 1, 2, 3, 4, and moving 2 units up, 1, 2. So this is our coordinate D. So that coordinate reads -3, 7. And that would be your answer. Question number 2. Geeta has a box of toys. She picks a toy at random from the box. The probability that she picks a wooden toy is 0.6. Work out the probability that she does not pick a wooden toy. So, the probability of not picking the wooden toy, let's just notate that with W prime. Okay, so the probability of not picking the wooden toy is 1 minus the probability of picking the wooden toy. In this case, this would be 1 minus 0.6, which lands you an answer of 0.4. 2b, the box contains 3 types of toys: wooden, plastic, or metal. Complete the table. Now, we know the probability that she picks a wooden toy is 0.6. So the probability she does not pick a wooden toy must be 0.4. So these two boxes that are seen here must eventually add up to 0.4 as your probability. Now, you can see here that in the box there are 14 plastic toys and there are 14 metal toys. This shows that there's an equal number of plastic and metal toys in the box. Therefore, the probability of picking them must also be equal. So since these add up to 0.4, each of these must be 0.2. And notice that your total probability still adds up to 1. Okay, so now we can compare this. 0.2 parts of your probability is equal to 14 number of toys. So to find 0.6 parts of your probability, we're just going to be multiplying by 3 on both sides. So 14 multiplied by 3 will give you 42. So that's 42 toys, 42 wooden toys. Moving on to question 3. The table shows some information about two sequences. We have sequence A and sequence B. Complete the table. So they've given us the nth term of sequence A and B. So that means the nth. So in order to find the fifth term, we're just going to have to substitute 5 as n. So n equals 5. Alright, let's start for sequence A. So the fifth term, I'll notate that with T5 is 60 minus 4 and substitute the n here with 5. So I get 60 minus 20, which is 40. And for sequence B, I'll do the same thing. The fifth term, T5, is equal to n squared, which is 5 squared, minus 300. Which will actually give me a negative answer of negative 275. And those are your two answers. 3b, find the smallest positive number in sequence B. So when they say positive, let's say this is x, your positive number any positive number would be more than 0. Okay, so sequence B is n squared minus 300. So we want the smallest positive number, so this number, whatever it is, should be greater than 0 in order to be positive. Okay, the way I will approach this is saying I move the 300 the other side, right? So negative becomes positive. Now I'm going to square root both sides, and this is the part where you have to be careful. When you're square rooting both sides, you are effectively getting a positive and a negative answer. So the positive answer should have no problem and would be greater than the square root of 300. However, your negative answer would switch your sign. Okay, because we know, for example, we have negative x greater than 1. In order to divide both sides by this negative number, you should switch your sign x as so. So this would be negative square root of 300. So obviously this inequality is rejected for the reason that we know n cannot be less than 300. Cannot be less than a negative number, it must be positive. So this should be your answer. Now square root 300 get us approximately 17.32. So any since this cannot be 17.32, okay, it must be an integer, n must be an integer, okay, n must be the 18th term in the sequence. So to find the 18th term in the sequence, substitute it back into sequence B, and now we're finding the 18th term, which is 18 squared minus 300. Okay, giving you an answer of 24. Question 4. Find the greatest odd number that's a factor of 140 and a factor of 210. Now, when we think of factors, we straight away want to construct our factor tree. So for 140, you're going to find two numbers that multiply to give back 140. Let's say 14 and 10. And do the same thing down again. 14 is 7 times 2. 10 is 5 times 2. And we stop when we cannot go anymore. Same thing to 210. I'm going to repeat. This is 70 times 3. 35 times 2. And 7 times 5. So expressing 140 and 210 as a product of its prime factors, I get 140 equals to 7 times 5 times 2 squared, because I have two 2's over here. And for 210, I will get 7 times 5 times 3 times 2. So if I compare the 140 and 210, I can see that I have a similarity of this 7 and 5. Therefore, the highest common factor between these two is 7 times 5, which turns out to be 35, which is an odd number, so we'll accept that answer. On to question number 5. For this, they are testing your calculator skills. So just when you are inputting this into your calculator, make sure you're inputting them correctly. So for the first one, you should get an answer of 0.6. For the second one, you do have to be careful when they give you both an addition and a multiplication together. Following bit mass or board mass, you are evaluating division and multiplication first before addition and subtraction. So you are taking 129 and 4 times 16. In other words, you are doing this: 192 plus 4 times 16. If that helps you see clearer, you will get 256 to the power of 1.25, which gets you an answer of 1024. Question number 6. The diagram shows 5 kites that are congruent to kite ABCD. Each kite is joined to the next along one edge. Angle DAB is 40 as shown here. And DCE is a straight line. So this right here, that is a straight line. So basically we have kite ABCD here. And we see 5 other kites that are congruent. When they say congruent, we are saying that they are the exact same. They have the same shape and size. So these 5 kites are exactly the same as this kite labeled ABCD. Alright. So now, since we know kites are quadrilaterals, the sum of interior angles in any quadrilateral will sum to 360. We will follow that same rule here. Since we know DCE forms a straight line, we know that straight lines have 180 degrees. So this 180 degrees is shared between 6 angles. Each of these angles are exactly the same. To find the value of one angle, we're simply taking 180 degrees, dividing it into 6 parts here, which will get you an answer of 30 degrees each. So each of these are 30 degrees, and so on. So now we know that this is 30 degrees, and we know this is 40 degrees. We know that in a kite, we also know that this angle is equal to this angle. So to find one of these angles, we're finding the value of x, which is one of these angles, which we know will be the same as this. To find that, we're taking 360 degrees, which is the sum of interior angles in a quadrilateral, subtracting off 30 degrees from one of these and 40 degrees from this end, and dividing all of this by 2 to find the individual angle of 1. That will give you an x value of 145. Question 7. The diagram shows a shape made from a triangle JKL and a semicircle with diameter JL. JKL is an isosceles right angle triangle, so we know this side is equal to this side in length, and we know that this is a right angle. Calculate the area of this shape. So to calculate the area of this shape, I'm going to break it up into 2 parts. We have to calculate the area of triangle JKL, and we have to find the area of the semicircle JL. We're going to first start off with the triangle. Alright, so the area of a triangle can be found using the formula half times base times height, or base times height over 2, whatever suits you. So the base and height are perpendicular to each other. In this case, they are equal. 81.92 cm squared. And for the area of the semicircle, we know the formula for an area of a circle is pi r squared. So the formula for an area of a semicircle should be this divided by 2. So the area is pi. R is your radius, which is half the diameter. The diameter in this case is 12.8. So half of that is 6.4 squared divided by 2. You have 512 over 25 pi. We'll simplify that down further later on in our calculation. So the total area of the shape would be found by adding these two together, which gets you an answer of 146.2598 and so on. But rounding to 3 significant figures, this gives you an answer of 146 centimeters squares. Part B, calculate the perimeter of the shape. So the lengths we need to measure are the one in red. So we know this is 12.8. but we want to find this slanted length or the hypotenuse of this right angle triangle. To find that, we can use Pythagorean theorem. Line KL is equal to the square root of 12.8 squared, which is this length squared, and the other length 12.8 squared, which gets you an answer of 64 square root 2 over 5 as seen by the calculator. Now this part of the circle, you know the full circumference of the circle can be given by the formula pi d, but since we're only finding half of it, you have to divide it by 2. D represents the diameter, which in this case is 12.8, and then you're dividing this by 2, so you get an answer of 6.4 pi in terms of pi. So you have to add 12.8 and 64 square root 2 over 5 and 6.4 pi, which gets you an answer of 51.0 centimeters, correct to 3 significant figures. Question 8. These are the first 5 terms of a sequence. Find an expression for the nth term of the sequence. So nth term of the sequence you can find by using the formula a plus n minus 1 d. Recall that a is the first term of the sequence, t1, n is your nth term that you're trying to find, and d is your common difference. So to find each of these, first let's start with our common difference. So from the first term to the next, we are adding 7, and so on. The common difference is adding 7, and we know the first term as seen here is 11. So substituting all of these except for n, and expanding, gets you Tn equals to 7n plus 4. Question 9. The value of a car is 8,000. Each year, the value of the car decreases exponentially by 25%. Calculate the value of this car after 3 years. So, at the start, year number 0, the car is worth 8,000. Okay. At the end of the first year, year 1, it would have decreased by 25%. So 8,000 decreased by 25% means you're multiplying by 100% minus 25%, which is the same thing as multiplying by 75% or 0.75. This continues on. Year 2, it is 8,000 times 0.75, which is the amount from year 1, and multiply another 0.75 to decrease the value of it again by 25%. So at year 3, at the end of year 3 or 3 years, the value of the car would be shown by this formula. The value will be P times 1 minus R over 100 to the power of n. P is your principal amount, the starting amount, 8,000. We know this inside is 0.75, we found that, and this goes on for 3 years. You will get an answer of 3,375. So after 3 years, your car will be worth 3,375 from the original 8,000. Question number 10. Amira invests 1,500 in an account. So consider this your principal amount. We have an interest rate of R% per year, and at the end of 8 years, his value of investment is this. So we're applying the same formula. Value of investment, or VOI, equals to your principal amount times 1 plus In this case, we're adding, instead of subtracting, because we are adding an interest rate on top of our principal amount. 1 plus r over 100 to the power of n. So your value of investment is 1,656.73. Your principal amount is 1,500, and inside remains as 1 plus r over 100. And we know this has been in there for 8 years. So dividing both sides by 1,500, on the left side you get 1.1044867 equals to 1 plus r over 100 to the power of 8. And now we're taking the 8th root on both sides. Then you're left with 1.0125 equals to 1 plus r over 100. Finally, doing a bit of simplifying gets you an r of 1.25. Question 11. Find the inequalities that define the unshaded region R. So we want the unshaded region. So we're looking at here. So the inequalities we define must be directed towards inside rather than all the shaded region. Okay. Some important things to go over first of all. When you have a straight line, this shows that the inequality can either be this, less than or equal to, or more than or equal to. Your line is dotted, then this will only represent inequality that is greater than or less than. Alright? Now, when I have a line, let's say that if I define the line to be y less than k, and this k can be any value, okay, or let's say this k is this line, right, whatever this equation of this line is, then y will be less than. When we look at y being less than, we look at anything below the line. So this is the region we're talking about. In other words, if I have a random line, this part can use to be represented by y less than something, because imagine a random horizontal line and the y is below and y is less than, so y is below this point, or it can be used to represent x is more than something, and this something is the equation of this line. Yeah, so if x is more than something, it lies to the right. Conversely, at the top of this can be used to represent y is more than k, or x is less than k. Y more than k meaning, if you imagine a horizontal line, anything that lies above this line or to the left of this line is bounded by these inequalities. With that out of the way, let's get into this. So I'll first start off with the easiest one, which are these horizontal lines. Okay. So we'll start off with this horizontal line. Now, always first of all, imagine that that line is an equation. Y equals something or x equals something before we insert our inequalities. In this case, a horizontal line would mean a constant y value, because at this coordinate, for example, your coordinate is 2, 5. At this coordinate, your coordinate will be 4, 5. As you can see, the y value is constant. So this is a line of y equals something, and that something is 5. Any coordinate that lie along this straight horizontal line will have a y coordinate of 5. Similarly, we can also do it to this bottom horizontal line, which has an equation of y equals 1. Okay, this vertical line is also straightforward enough. Okay, Since it's vertical instead of horizontal, it's going to get me x equals to something. If I get this coordinate, for example, I'm going to get a coordinate of 6, 2. If I use this, I'm going to get a coordinate of 6, 4, and so on. So as you can see, my 6 stays constant, so this is x equals 6. And finally, this slanted line. So this slanted line, you have to find the equation of the line. How do you find the equation of the line? First of all, let's find the gradient of this line. So to find the gradient of this line, we see per x value, how much does the y increase by? So as you can see here, for one unit move to the right on the x scale, we move 1 unit up on the y scale. Again here, 1 unit to the right, 1 unit up. Okay, this shows us that our gradient is 1. So this is y equals to x something. Okay, so now we need to find our y-intercept. So if we continue on as to just continue on this line, you will see that it will intersect y at 0. So this is the equation of y equals x plus 0. In other words, it's the equation of y equals to x. Alright, we have our 4 equations now. Y equals to x, y equals to 1, x equals to 6, and y equals to 5. However, the question is asking us for inequalities, not equations, so we need to turn all of these equations to inequalities. First step is to identify whether there is an equal sign underneath or not, using the rules here. This is a bolded line, so it would follow this top rule. Either less than or equal to more than or equal to 5. Just replace the equal sign to one of these inequalities. Now, since we are defining the unshaded region, we're looking at below here, because this is the unshaded region, remember? So below this line, remember, we looked at less than, because we are looking at this in terms of y instead of x, so we're looking at below, so we're looking at less than or equal to. That's your first inequality. Next one, x equals to 6, so this will be x and some inequality. This time it's dotted line, so we have to follow the second rule. And since the region we're defining is to the left of this line, using this rule right here, we have to use less than. Okay, for this one, once again, y and 1. Now for the inequality, since we're looking at above, and since this is a bolded line, your inequality will look like that. And finally for this one, you have y and x. Since it is a dotted line, we're using the second rule. Now in terms of the y perspective, this is below this line, or the unshaded region is below this line, so it will be less than. If you look at it in the x perspective, then the unshaded region is to the right of this line, so it will be more than. So either way, this inequality will work. So your final answer then will be. However, notice that these two have both have y in it. So in reality, we can actually combine this. When we combine this inequality, we are going to get 1 less than or equal to y, which is less than or equal to 5. So these are your 3 inequalities. Question 12. Solve the simultaneous equation. You must show all your working. So there are 2 methods to this, the method of elimination or the method of substitution. Okay, we're going to do the method of elimination here. So let's say this is equation number 1 and this is equation number 2. First of all, we need to manipulate equation 1 and or equation 2 in order to have the same coefficient in front of x or y. So for equation number 1, I'm going to multiply this . I'm going to multiply this by 8. So this gets me 8 times this, which is just 12x, plus 8 times 5, 40y, equals to 40. Then for equation number 2, I'm going to multiply this by 3 to get me 12x minus 9y equals to 138. Now I have the same x coefficient. I can straight away subtract them. So 12x minus 12x is 0 or nothing. 40y minus negative 9y, in this case is 40y plus 9y, 49y. And this 40 minus 138 will get me negative 98. So in this case, y equals to negative 2. Using this, substitute it into any one of these equations. Okay, let's say I choose equation 2. It can be anything, yeah. Up here, 4x minus 3y equals to 46. Substitute y equals to negative 2. And then solve as usual. Your x will give you an answer of 13. That's the first method of elimination. Okay, this is method number 2. First of all, manipulate equation 1 or 2. This time just choose one to make x or y the subject of it. So equation 1 starts off with 3x over 2. I'm going to move the 5y to the other side to make x the subject. So 3x is equal to 10 minus 10y. Multiplying this 2 to both sides or both terms, and x equals 10 minus 10y over 3. Substituting my expression of x into equation number 2 now, I get this, which when expanded will give me y equals to negative 2. Then again, substitute it into your x. So x equals to 10 minus 10 negative 2 over 3, which I'll get 10 plus 20 over 3, which is 10. So your answer would then be x equals to 10 and y equals to negative 2. Question 13. This is a circle theorem question. So you do have to memorize your circle theorems for you to be able to solve this. Diagram shows a cyclic quadrilateral, and all cyclic means is that all corners or vertexes of your quadrilateral or any shape are on the circumference of the circle. Alright, so when we see a cyclic quadrilateral, a circle theorem tells us that opposite angles in a cyclic quadrilateral are supplementary. And all supplementary means is that they add up to 180. So over here, 4m and 5m adds to 180. With this, we can find m, which is 20. So substituting 20 into here, we get 80 plus 38, which is 118. So we know this part is 118. So p plus 118 must be 180 due to the circle theorem. Therefore, p will be 60. Question number 14. This diagram shows a circle with radius 9. Calculate the area of the shaded major sector. So if we want the area of a sector, we have to use the formula. Area of sector equals to theta over 360 times pi r squared. So this is the proportion of the whole entire circle, which is this formula, that we're finding the area of. So what is theta? Theta is the proportion of the circle we're trying to find. Since we're trying to find the shaded area, which is this large major sector, the angle is this one instead of 48. This is 360 minus 48, which will be 312 degrees. Okay, so over here, 312 over 360 times pi r, your radius is 9 squared. You get 351 over 5 pi, which is approximately 221 cm squared to 3 significant figures. Question 15. Write 0.146 recurring as a fraction in its simplest form. So when we say 0.146 recurring with the dots on top of 4 and 6, all we really mean is 0.1 and 46 keeps repeating. 46, 46, 46, and on and on and on. So to write this as a fraction, let's first let x equal to this 0.146, 46, 46, 46, and so on. Now, we have to count up to the point where the first recurring pattern ends. In this case, it's 1, twice, 3 times, because after this point, the recurring pattern of 4, 6 repeats again, so we're not counting this part. So since we are rolling 3 times, effectively what I want to do is move these 3 digits to the front, like so. So to be able to do that, I am multiplying by 1,000. So I will have to multiply by 1,000 on the left side as well. Okay, now I'll diverge away from this for a while and look at this again. I noticed that this one isn't recurring, but however I've included in the rolling of this because it was compulsory, because I wanted to end here where the recurring restarted again, but evidently I included the 1. So in order to, because this one is not recurring itself, okay, I will also have to roll once to the 1. So in this case, I will get 10x equals to 1.4646 recurring. So now I have these two, 1000x equals to this value and then 10x equals to this value. Now what I can do, you can observe that both of these have the decimal of 464646 recurring. So I can actually subtract this. So 1000x minus 10x, I just get 146 minus 1, because all of these decimal cancel out when I subtract them. So over here I get 990x equals to 145, in which case solve normally for x, 145 over 990. Question 16. In the Venn diagram, shade the region M complement intersection N complement. So recall that when we have a set, okay, let's say we have a Venn diagram. Okay, let's say this is set A, this is set B, and they are all within the universal set. Okay, so when I say set A complement, I mean everything apart from set A. So set A is bounded by this region, including the intersection with B, because that is a part of this section A. Now when I say A complement, I mean everything else from it. So all of this. Okay. And when I say B complement, let me use a separate color. I mean everything else from the region bounded by B, which is all of this. Right? Because B is bounded by this circle. So everything outside of this circle that marks B is B complement. Now when I put an intersection sign, this upside down U, that's an intersection sign, which means where both of these events intersect or occur together. So as you can see, where the purple and black markings are together is only around this spot. So that will be the answer for this. M complement intersection N complement will be everything apart from these two circles. So you can just shape that. Alright. Okay, part B. Find N when they say N is the number of items in this event. Okay, let's break it down slowly. There's two brackets, so we'll start solving the inner bracket. This is A complement union. This upside U means union. For example, if I have this universal set and I say A union B, I mean set A, which is this, and set B included, which is this. So basically everything that bounds at A and B. So A prime union C, A prime is anything other than the circle of A or the set of A, which is all of this. And union C means anything in the set of C or in the circle of C, which is all this. Okay, using a different color. Now we want to find B intersection. So where set B intersects with all of these black sketches, which is over here. Set B, remember, is this circle. This 16 is not included because I never shaded it. So now basically I have all of this. I'm only counting everything in set B except for the 16. So now if I erase all of this, I'm counting 10, 4 and 3, which together gets me 17. Question 17. We have a triangle. Calculate the area of triangle ABC. Now, if we're given no information about the perpendicular height, things like that, there's no use trying to use this formula. Instead, we have to use the formula from trigonometry, which tells us that the area of a triangle is half AB sine C. In other words, half multiplied by the length of one side and the length of the adjacent side, the sides touching, and those two sides must have an included angle, and that's where you insert your sine C. So over here, that will be half times 6.7 times 5.9 times sine 81 degrees, which gets me an answer of 19.5 cm squared to three significant figures. Question number 18. So we have this graph here. The diagram shows the graph of this equation for negative 3 to 1.5. So this is your domain, negative 3 to 1.5, your x range, your x domain, sorry. By drawing a suitable straight line, solve the equation this. Now, first of all, before we go into solving this, we have to compare it with each other. So this is your original equation, and this is my modified equation. What can you see is different? I see this x cubed plus 4x squared minus 2. I see it here. It's the same. But instead of y now, I see 2x on the other side. That means this x cubed plus 4x squared minus 2 is this graph. But I see 2x on the other side, meaning I want to see when this graph intersects with the line y equals 2x. Okay, because I have two equations now. Y equals x cubed plus 4x squared minus 2, which is this side, the left side of the equation, and I also have y equals 2x, which is this right side of the equation. Okay, so now I just make a random table of values, just so I have some points to plot on the graph. -3, -6, but that's out of the range, so I don't have that. -2, -4, that's also out of the range, but if I put -1 and I put it into this equation, I will get this coordinate, followed by this and that. So that's enough points for me to trace out a straight line, like so. Now, once you've drawn the line, you will see 2 points of intersection, which is here and here. From there, read off your x values. Over here, I have, and over here, I have an x value, something like that. So, reading off these, I have 0.5, x is -0.5, and x is 0.9. So those are my two x values. Question number 19, factorize completely. Okay, so first of all, let's take out any common factors we see. Between 12 and 75, I see the common factor 3. So taking out a 3, I get 4m squared inside minus 25t squared. Now over here I see a difference of 2 squared. This is 2m squared and this is 5t squared. So together, using my difference of 2 squared formula, I will get 3 times 2m plus 5t times 2m minus 5t. For part B, we are doing 4-factor grouping. So before we start 4-factor grouping, we want to move around terms so we have something to factorize. Right now, x, y, and 15, there's nothing common to factorize. So let's say we move this 3y beside the xy. So now I have this. Again, it's just rearranging it around. So I have something to factorize. Here, I have a common y, so I take out that. And for the third and fourth term, I can take out a common factor of 5. And now I see x plus 3 here and x plus 3 here. Bring it into one bracket. And the remaining, that is not within a bracket, put it into another one. That's your fully factorized form. Question 20, solve the equation 8 sin x plus 6 equals 1. So this is a trigonometric equation for 0 to 360 degrees. So first of all, rearrange this. 8 sin x equals to -5, moving the 6 over. And sin x equals to -5 over 8. So to find x, or in other words, to find alpha, which is our basic angle, we're taking sine inverse of 5 over 8. Because we can't take the inverse of sine of a negative value. So if you take a positive value, putting this into your calculator, you will get about 38.68 degrees. Now, recall that this sine value is negative. In your 4 quadrant, A, S, T, C, we recall that sine is positive in quadrant 1 and 2 and negative in quadrant 3 and 4. Because all is positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cos is positive. Cos is positive in quadrant 4. Otherwise, everything else will be negative, except in quadrant 1. So sine is negative in quadrant 3 and 4. So if we have a theta angle here, for example, this will be 180 degrees plus your angle theta, and over here it will be, if your theta is here, this will be 360 degrees minus theta. So this is our quote-unquote theta, this is our alpha, our basic angle. So substitute it into these two for quadrant 3 and 4. So your x value will be 180 degrees plus 38.68 degrees and x will also be 360 degrees minus 38.68 degrees. Those are your two answers. Question 21. Diagram shows a cuboid and we are given all this information about their lengths, which are here. Calculate the angle between CE and the base. So the angle between CE and the base is this angle. Okay, imagine that one. It's an elevated angle of elevation. Okay, so to be able to get that, we first need to find this. Okay, to find that length, we know that this is 9.1 cm, copying it from this top here, and this is a right angle in this cuboid. So using Pythagorean theorem, we can find CH as the square root of 9.1 squared and 4 squared. Which will get me an answer of 9.94032. Okay, so now that I have that, we also know that this is also a right angle. So I have this as approximately 9.94032. So I can find this angle. This angle, relation to these two sides, this is the opposite and this is the adjacent. So the trigonometric ratio that links opposite and adjacent is tangent. So tan theta, which is the angle we're trying to find, equals to opposite, which is 6.5, divided by the one we found, 9.94032. So theta is the inverse of this. Which will get you 33.2 degrees to 1 decimal place. And finally, question 22. Bag A and bag B each contain red counters and blue counters only. So in bag A, okay, I have two types of counters. I have red counters and blue counters. And in bag B, I have the same. I have red counters and blue counters. Stefan picks a counter at random from bag A, so Stefan picks from here, and Jen picks from here. The probability that Stefan picks a red counter is 0.4. So red 0.4, and the mixed probability is 0.25 that they both pick a red. Okay, so from this information, we can say since the probability that Stefan picks a red is 0.4, we can say that the probability of Stefan picking blue is 1 minus 0.4, which is 0.6. So that's the other end of the probability. Now, this mixed probability, what can we do about that? The probability that Stefan, I'll notate that with an S, Stefan picks a red, and remember the symbol, this is and, Jan picks a red is 0.25. Now we know now just as a quick side note, we know that the probability of A and B is the probability of A multiplied by the probability of B. So applying that idea here, this is the probability of Stefan picking red multiplied by the probability of Jan picking red will be 0.25. We know this probability is 0.4 from up here. So we just have to find this probability. Using simple equation manipulation, your P will be 0.25 divided by 0.4, which is 0.625. Okay, so this is 0.625 that Jen picks a red counter, so therefore probability that she picks a blue counter is 0.375. Okay, so find the probability that Stefan and Jen both pick a blue counter. So once again, applying the same rule, we're finding probability of Stefan picking blue times probability of Jen picking blue, 0.6 times 0.375, and that will get us 0.225, and that. Alright, so that's the end of this paper, 0580 paper 2-1 from the May June 2024 series. I hope you found this video useful. I'll see you guys in the next video. Goodbye.